One of the largest hurdles for any new FTC team is going from a built robot to one that actually moves. And that all starts with your very first program. By the end of this video, you'll have written your first functional Java program for FTC, and you'll understand exactly what each line of code is doing. This is the foundational skill that will let you control motors, read sensors, and ultimately build a competitive robot. My name is Coach Pratt, and for over 10 years, I've taught robotics and design. I've coached FTC teams to national championships and multiple Inspire Award wins. I've seen countless students start exactly where you are now, with zero programming experience and feeling intimidated to start with scripting or wanting to move away from the simplicity of block-based coding. Don't worry, I'll guide you through every step of the way, and I guarantee you'll come out of this with the confidence to write your own programs step by step. So in this video, I'm going to run you through the absolute basics. We'll start with some quick terminology, then define what an OpMode is and why it's so important for your robot. From there, we'll write our very first program together, step by step, and I'll break down what every part does. I'll show you the most common reasons code doesn't work in case you run into some problems. And finally, I'll give you some practical exercises with some solutions to solidify your new skills and get you practicing your new programming fast. Now, before we get any further, we have to talk a little bit about some terminology in Java. First thing to know about is a class, and a class is effectively just a group of code that's shared. We'll talk more about what classes are later on, but for now, just know that it's kind of like a file where you have a section of code in one. In Java, all code is inside of classes, which is a little bit different if you are familiar with other programming languages. There's also methods, and a method is a group of code. You can think of it like a set of instructions that they follow. So you have a method or a function that you run for brushing your teeth. You put toothpaste on the toothbrush and then you brush your teeth. Same thing in Java. You might have a method for lifting your robot arm off of the floor. We'll talk more about this later, but effectively it's just a group of code that runs at the same time. There's also a package. A package is a directory in Java for where you store your class files. It effectively allows you to be able to access information and let which pieces know which pieces have that information. You think of a package like a house address, effectively. If you're inside house address 19, then you get access to the files that were within house address 19. Now let's talk quick about an OpMode. An OpMode are things like your TeleOp and your autonomous. Your first 30 seconds of the match or the last 2.5 minutes, where it's the driver-controlled or teleoperations period. All OpModes have to have two methods or two groups of functions. Two groups of code. You have to have an init function. And init is short for initialize. So this rides once you press the init function on your driver hub. The second one is a loop, and this is code that runs repeatedly over and over and over and over again. The thing to know about robots is that robots are sensing, thinking, acting machines. So they're going to sense their environment with some sort of external sensor, be it a camera, be it a touch sensor, be it a color sensor, whatever that is. Then they have to think, okay, if the color is red, I'm going to close the claw. And they have to act, which is I'm actually going to close the claw. So robots are sensing, thinking, acting machines, and they do it over and over and over again in a loop. There are also 3 more optional methods that you can run. Your initialize loop, your start, as well as your stop. These are a lot less common. We're not going to use them very frequently, but recognize that they do exist and you can use them if you need to. This screenshot is taken from Alan Smith's great book on Learn Java for FTC, which I highly suggest you take a look at for some further learning on top of these videos. So traditionally, in every single programming learning tutorial course, you write a program called Hello World, which is effectively a way to have your computer, your robot, whatever, speak back to you. What's a little bit different in embedded programming or in robotics is that rather than your computer speaking back to you, you actually have the robot controller speaking back to you. So let's go ahead and write our first ever program together to actually have our driver station talk back to us instead of our computer talking back to us. So first thing I'm going to do is I'm going to make sure that I have my robot controller project open. This was the one we created in that last video. Then I'm going to come down to the team code section. You do not want to add any code to this FTC robot controller section because that is the master example code from the FTC SDK. Instead, I'm going to come to this team code folder. I'm going to come down to Java and this org.firstinspires.fc.team code. This is that package that we were talking about earlier. So I'm going to create inside here. I'm going to go ahead and right click, select new. I'm going to select a new Java class. And if you remember, that class is just that group of code for things. So I'm going to create this as a class. I'm going to call this one Hello World. In Java, classes follow something called Pascal case. It's just convention. So I have a capital H and a capital W as well. And then I'm going to go ahead and press return to create my new class. Now it's going to ask us if we want to add this to our Git. We always want to add this to our Git. So I'm going to say, don't ask again. I'm just going to click add. We'll talk more about what that means later, but effectively, if we have this set up in GitHub Desktop, this is going to allow it to add it to our GitHub repo so that we can save our code over time instead of just saving it just on our computer. Now, there's a few things that automatically get added in for you here. The first is the package for the org.firstinspires.ftc.team code. This adds in all those different methods and a lot of those different features that we can pull in from the FTC SDK already created. So that's really helpful. You notice we have something new here called a public class Hello World. Now this is our first class, which is a Hello World. We're going to write in something here called extends, and then we're going to put in a capital O, P, and then OpMode. I can go ahead and double click on this OpMode, and it automatically puts in some code for me. This is the real beauty of using Android Studio, because now we get to see our first import statement. This basically lets us know that we are using some code from the First Inspires package, and we're using an OpMode from the FTC SDK. So that our Hello World class is actually part of the OpMode, or it extends the OpMode. So you can kind of think of the classes as parents and children are part of. Sometimes I explain it like thinking about animals. So for instance, if you are a cat, your features about you are that you have 4 legs and you likely have a long tail. So all cats are going to have 4 legs and a long tail. Yeah. So if you were, say, a house cat extends cat, it's going to have 4 legs and a long tail. Tiger also extends a class of cat. But obviously a house cat and a tiger are 2 different things, but they're both going to have 4 legs and a long tail. So that's effectively what we're doing. It may seem a little confusing now. It'll make more sense as we get further into it. I'm also going to come up here to line 4 here. If you look on the left-hand side, there's numbers for everything, so we can keep track of what line we're on. I'm going to go ahead and put the @ symbol. I'm going to say @TeleOp. You can either double-click on the TeleOp here, or you can press Tab on your keyboard. It'll automatically complete that for you. You'll also notice that there was a new import statement that just popped up. Nice thing about programming in Android Studio is it automatically puts these import statements in, so that when we call this TeleOp, it's automatically adding in things in the back end for us that our code's going to need. Now, this @TeleOp line is absolutely critical. If you forget to put in @TeleOp, your code will not show up on your driver station. You have to put in either @TeleOp or @autonomous. If you remember in your driver station, always have to have @TeleOp or @autonomous in either of your opmodes. Now, this word public basically means that other places can see this class. It's required in order for our driver station to be able to see our code. And our class is the Hello World. And again, we already talked about it extends OpMode, like it's pulling in those additional features from that species that's above it. In Java, these are called childs. Kind of like how you are a child of your 2 parents, and your parents have specific traits that get inherited into you, specific height, skin colors, eye tones, hair shade, things like that. You are extending traits and characteristics from your parents. Now inside this, we're going to go inside these curly brackets. I'm going to start writing in public void init. So I'm going to use my arrow keys to select this. I'm going to press Tab. Now it's just added a whole lot of new things for us. We have this @override. We have this public void init inside, and it's all inside the curly brackets that we've been working through. Now this @override means that the OpMode class that we're extending from has an initialization method. We are overriding that initialize method because we're writing our own initializing method. So we are replacing the functionality of that initialize method into our own initialization statement. So public, again, means that other classes can see this. And void means that it just doesn't do anything. We have to say public void because we're not going to do anything with this information. We'll talk more about that later. But we're going to create our initialization or our init method. And the only thing we're going to add to this is telemetry. I really like using autocomplete. The reason I like using autocomplete is I'm spelling mistakes a lot when I'm typing. So using that tab function on your keyboard really helps. We're also going to use something called dot notation. So I'm going to put a period here. And what dot notation lets us do is lets us show a whole bunch of different things that we can do with telemetry. Telemetry is a really, really big object. It's got a lot of things that we can do. And by using this dot notation, it allows us to call methods that are attached to those objects themselves. So telemetry is an object, and we can call methods that are, so just like we're writing our own void init method, we can also grab something like add data. Add data lets us add data to the screen of that. So I'm going to go ahead and put in a quotation marks. I'm going to say hello. Oops. Put a comma after it. And then I'm going to put another string and say world. At the end of this, I'm going to put in a semicolon, the dot with the little slash down at the bottom. And what this line does is this puts the word hello and world, printing it directly to our screen so that we can see it on the driver station. The important thing to note is that all statements, or the vast majority of lines here, are either going to end in a semicolon or a curly bracket. You notice above, all these statements end in semicolons. This one also has to end in a semicolon. Now, if we were to run our program right now, it's not actually going to work. The reason it's not going to work is because all OpModes, you remember from earlier in that graphic, they need an initialization method and they need a loop method. So I'm going to get out of these green curly brackets. I'm going to go ahead and click public void, and we notice that that public void loop is automatically showing up for us. Press return to auto-complete that. It automatically puts that in that override. You remember that override is overriding the loop method that exists inside the OpMode class. And for this one, we're actually not going to put anything in it. We're just going to leave it empty. And that's okay. You can have nothing happening inside your loop. You can have a completely empty method that basically does nothing. So let's go ahead and actually run this on a device. I'm going to go ahead in the top of Android Studio. You have to make sure that your Rev Robotics Control Hub 1.0 is connected. At this point, I am simply happy. I have the Control Hub connected to my computer via a USB-C cable. Now keep in mind, you have to use a USB-C to USB-A on your computer. So now I'm going to go ahead and I'm going to click this little Run Team Code button. So this is going to refresh. It's basically going to build your code. It's going to compile it, and then it's going to put it or download it onto your Control Hub station, where at which point it should show up on our controller hub. Once it is fully built, it should go whoop, 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 and you'll hear a little beep beep on our driver station. Here you'll see over at the driver station that my control hub is currently flashing blue, and I've just disconnected from my robot. It's flashing blue here to let us know that it is currently compiling some code on the control hub. And then we just need to wait a little bit longer. Sometimes you have to wait 20 to almost 30 seconds using it through Android Studio for it to actually connect. And there we go. We managed to connect. Normally you would hear a boodoo, but unfortunately my audio broke. So taking a look at the driver station, there's these two little white arrows. This left side is for autonomous, this right side is for the TeleOp. Because we wrote this for TeleOp, we can go ahead and tap Hello World. That's the name of our program. When we tap this initialize button, it's actually going to run that init method. And the method we had simply stated Hello World. So now if I were to click the play button here, that would end up running the loop method. But of course, we have nothing inside that loop method. Let's talk a bit about some common problems that you might run up if your code didn't compile. One of the first ones is that Java is case sensitive. So for instance, if I were to say public with a capital P here, you'll notice that it shows up red saying, hey, we cannot resolve the symbol public because we don't know what public is with a capital P. So you're going to make sure you do that as a lowercase. I'm also going to go ahead and try to build this. So I'm going to click this little rerun or this little refresh button. You notice that down at the bottom here, we end up with an error. Error identifier expected public void init. So that should let us know that, okay, yeah, we should probably do that lowercase. So that's a big one. Same thing with this telemetry.add data. You notice that it has to start with a lowercase a as well as a capital D. So if we say add data that way, or if I were to say add data, again, it's going to end up throwing us a bit of an error here because add data shows bright red. So I'm going to go ahead and make that a lowercase. Another thing to note is that white space or spaces, the computer completely ignores. It's simply to make things easier. So you could write your code like this. If you wanted to, that's perfectly acceptable. I like to add a little bit more white space to my code because it makes it a little bit easier to read. And by doing that, the computer ignores it, but it makes it way easier for humans to read. The biggest thing that I can tell you when you're learning how to program is that coding is for humans to read, not for computers to read. You have to be able to understand your code. Adding this white space does not make it run any slower, and it doesn't make it any more efficient by taking the white space out. All it does is slow down your programming time. You have to know that blocks of code are separated by these curly brackets. So for instance, if you wrote these outside of the curly brackets, this is why I like the rainbow brackets. So we can see that when I click this, the yellow bracket has all of this code inside of it. This green bracket has all of this code inside of it. This green bracket has all of that code. So that rainbow bracket extension is super handy. All your parentheses have to have an open and close. If you miss a parenthesis, you'll notice that this one is now highlighted white and it's got a little red arrow. That means that there is no parenthesis that closes it off. I could technically close it off over here, but again, it's going to throw me a bit of an error. So I'm going to make sure that I have all of my parentheses matching up. Another one that's really common is that you could have forgotten to put in semicolons on statements. Typically, if you forget a semicolon, you can look at the end here and even on a right browser there, it's going to say expected a semicolon. So we should put that in at the back because it's the end of a statement, so it needs a semicolon. So now let's talk a little bit more about comments. I'm going to add in something. This is a single line comment, and the computer completely ignores it. I can add as many comments as I want here. I can also add something called a block comment. I can put a slash asterisk, and anything in between these two slash asterisk slash is going to be completely ignored. So let's do a little bit of practice on your own time. So the first thing I want you to try to do is I want you to try to change this. So instead of saying hello world on the telemetry data, I want you to change the telemetry data to display hello, your name. So that's your first challenge. Pause the video here, see if you can change this to display your name instead. So the solution to that one, really easy, up on here on line 13. Instead of saying hello, comma, world, you can write hello and then your name. In my case, I'm Coach Pratt. So if we were to run and build this code over, it should pop up on our driver station. It's going to disconnect. Let's take a look at that. We've seen that our robot controller is disconnected. We know that it's starting to currently build that code because it's flashing blue on the control hub. And we just have to sit and wait until this reconnects. Again, sometimes it can take anywhere from 20 to 30 seconds. Sometimes it's as fast as 15 seconds. Just takes a little bit of time. Android Studio just says that the install was successful. It took 19 seconds. So this is our build time. And then we're now going to go onto our back of the driver station. Notice we're now connected. So we can go ahead and tap on TeleOp and then select our Hello World program. And when we click our initialize, it's going to run the initialize method. And now it says Hello Coach Pratt as opposed to Hello World. So now let's do test number 2. What I want you to try is I want you to run this code in the autonomous section of your driver station rather than your TeleOp station. So take a look, see if you can figure out how to run this in autonomous, not in TeleOp. So this one should be pretty easy. Instead of at TeleOp, we're going to write at autonomous. We're going to crack this little run so that we can build this and then install it onto our control hub. Now you'll notice that as we added in all these comments, it didn't actually change the functionality of the program at all. Regardless of where we added these comments, the computer completely ignored them because it's just for us to keep track of. Yeah, it's for notes for programmers, which is really useful. So let's go ahead and take a look at our driver station. It's still about disconnected, and we're waiting for this to actually build up onto our program. Sometimes making frequent code changes in Android Studio can take some time. There we go. We've got it now connected. Now we'll be running TeleOp. You'll notice that there's nothing in TeleOp anymore. If we select autonomous, we can now select Hello World as an autonomous. We click our initialization. It should say Hello Coach Pratt. So that is your very first program up and run. Let's talk about a few more things before we finish, because in the previous tutorial, we talked about forking a GitHub tutorial, and we need to actually save our projects properly. So let's go ahead and take a look back at our desktop. The first thing we're going to do is we're going to go ahead and disable this project. We still want to keep the code, but we don't want it to show up on our control hub. So I'm going to write that at disabled with a capital D. And what that's going to do is it's going to keep that code inside of our team code folder. But when we go to run our control hub or our driver station next time, instead of having in our autonomous section here, having a hello world, nothing would show up. It would look the same as our TeleOp section where there's nothing inside. For instance, if you look at this FTC robot controller, you can see just how many classes exist. If we had this many classes or inside of our robot controller, we don't have to scroll through 700 times. So we can use this @disabled to be able to remove this from our list of programs that we can write. Instead of having to remove it from a repository, we can just disable it so it doesn't show up in a robot controller. So last thing we're going to do is we're actually going to save this over to our GitHub desktop. So you actually don't need to Command S or save any files in Android Studio because any changes you're making automatically get changed on Android Studio. So let's go ahead and let's open up GitHub desktop. And you'll notice that in GitHub desktop, there's now some new changes here. We have one changed file, this team code, source, this is basically where it's saved. And all of this green are any new lines that we've added. So we added a new file called helloworld.java. We've added a new class. On GitHub desktop, you can keep track of your commits with summaries, like titles and descriptions. In this case, we have a create helloworld.java. That's a really descriptive title. And for our description, this is for you to keep track of your history over time. So I'm going to say, added in my first tutorial class. And then down here, you'll go notice that it says, you don't have write access to the FTC robot controller. Want to create a fork instead. If you remember from the last video, we talked about how we're going to create a fork where you have your master branch of the FTC robot controller, where it has all of the programs we have. And then you're going to have your own private fork that we can do. So what I'm going to do, I'm going to click this blue button here that says create a fork. We're going to fork this repository. And then we're going to select for my own purposes because we are not going to contribute to the parent project. We're not creating examples for other teams to use. This is just for our own repository. We'll click continue. I can go ahead and rewrite the description because apparently it rewrote that. So we're going to say created first ever Java line class. We'll go ahead and commit this to master. Yours might say main branch, but it's your master or main. We'll talk more about branches later or you can take a look at my other GitHub tutorials in the description down below for doing that. But for now, you can go ahead and click to master. And the last thing you have to do is make sure you push this to origin. If you just commit to the master, you're only saving this to your local GitHub repository on your computer. This doesn't actually have the benefit of GitHub, which is storing things online, kind of like a cloud storage, like Google Drive or iCloud or OneDrive, but for your code specifically. So now if I were to go up to repository, come up to repository and say view on GitHub, we should be able to see that we have all of our code written inside of our team code section. So if I clicked on 49 commits, I can click that now there was these other ones from the actual SDK, then you have my commit. So if you click in here, you can actually see that we created our first ever Java class and we changed one file. So now this file exists on GitHub servers and on your computer. So now if your computer ever crashes or anything like that, you've got your code saved. So let me know if you have any questions or comments down below. If something didn't work, put down a comment and maybe I can help you out in the comment section instead. Other than that, best of luck on building a robot and good luck out there this season.